The chemistry of color mixing and blending. Title: The chemistry of color mixing and blending. Introduction. Color is an integral part of our lives, surrounding us in all aspects of the world. From the vibrant hues of a beautiful sunset to the colorful array of flowers in a garden, our eyes are constantly captivated by the magic of color. But have you ever wondered about the chemistry behind color mixing and blending? In this article, we will delve into the fascinating realm of color and explore the intricate chemistry behind the process of mixing and blending colors. The basics of color. Before we explore the chemistry of color mixing, it is important to understand the basics of color. Colors are perceived by our eyes due to the presence and interaction of light. When light encounters an object, it can either be absorbed, transmitted, or reflected. The colors we perceive are a result of the reflected light. Color is determined by three primary properties: hue, saturation, and brightness. Hue refers to the specific color, such as red, blue, or green. Saturation refers to the intensity or purity of the color, while brightness refers to the overall lightness or darkness of the color. Primary colors. In color theory, we often refer to primary colors. These are the fundamental colors that cannot be created by mixing other colors. The primary colors in the additive color model are red, green, and blue, RGB, while in the subtractive color model, the primary colors are cyan, magenta, and yellow, CME. Color mixing. Color mixing involves combining different colors to create new colors. There are two main methods of color mixing: additive and subtractive. Additive color mixing. Additive color mixing occurs when colored light is combined. It is the principle behind how colors are mixed in electronic displays, such as televisions and computer monitors. In the additive color model, combining the primary colors red, green, and blue creates white light. When all three primary colors are mixed at full intensity, the result is a pure white color. Furthermore, additive color mixing follows the principle of an additive color wheel. This wheel illustrates the relationship between colors and their combinations. For example, mixing red and blue GHT creates magenta, mixing red and green light creates yellow, and mixing green and blue light creates cyan. Subtractive color mixing. Subtractive color mixing occurs when pigments are combined. Pigments absorb certain wavelengths of light and reflect others, leading to the perception of color. This method is commonly used in the printing industry and in traditional painting. When primary colors in the subtractive color model, cyan, magenta, and yellow, are mixed together, they create black. This differs from the additive color model, where all primary colors combine create white light. The subtractive color model works on the principle that each color subtracts or absorbs certain wavelengths, resulting in a different color being perceived. Color blending. Color blending involves mixing two or more colors to create intermediate or tertiary colors. This process of blending can be achieved by combining primary colors or by mixing primary and secondary colors. Primary color blending. Primary color blending involves combining the three primary colors to create secondary colors. For instance, mixing red and blue creates purple, mixing red and green creates yellow, and mixing green and blue creates cyan. Secondary color blending. Secondary color blending entails combining primary colors with secondary colors to achieve tertiary colors. This process expands the color palette and allows for a wider range of shades and hues. 4. Example: mixing red and yellow creates orange, mixing yellow and blue creates green, and mixing blue and red creates violet. Chemical pigments and dyes. The colors we perceive in everyday objects are often the result of chemical pigments or dyes. These substances possess specific chemical properties that selectively absorb and reflect light wavelength. HS, resulting in the perception of color. Pigments are insoluble and are typically found in solid or powdered form. They are widely used in the production of paints, inks, and other coloring materials. Different pigments derive their color from the presence of specific chemical compounds. For example, titanium dioxide is a commonly used white pigment, while chromium oxide is used to create shades of green. Dyes, on the other hand, are soluble in solvents and are often used to color textiles, plastics, and other materials. Dyes work by molecularly dissolving in a solvent, allowing them to penetrate the material being dyed. The chemical structure of dyes enables them to selectively absorb certain wavelengths of light, resulting in the perception of color. Color mixing and blending are fascinating processes that rely on the chemistry of light and pigments. By understanding the chemistry behind these processes, we can unlock endless possibilities for artistic expression and visual beauty. Colors are perceived by our eyes through the interaction of light. When light encounters an object, it can be absorbed, transmitted, or reflected. The colors we see are a result of the light that is reflected back to our eyes. To understand color mixing, we need to know about primary colors. In the additive color model, the primary colors are red, green, and blue, RGB. When these three colors are combined, they create light. This principle is used in electronic displays like televisions and computer monitors. On the other hand, the subtractive color model uses cyan, magenta, and yellow as primary colors. When pigments in these colors are mixed together, they absorb certain wavelengths of light and reflect others. This is the basis of subtractive color mixing, commonly used in printing and painting. Color blending involves mixing two or more colors to create intermediate or tertiary colors. Primary color blending combines the three primary colors to create secondary colors. For example, mixing red and blue creates purple, while mixing red and green creates yellow. Secondary color blending combines primary colors with secondary colors to achieve tertiary colors, such as orange, green, and violet. The colors we see in everyday objects are often the result of chemical pigments or dyes. Pigments, found in solid or powdered form, are insoluble in solvents and widely used in paints and inks. Different pigments derive their colors from specific chemical compounds. For instance, titanium dioxide is a white pigment, while chromium oxide is used to create various shades of green. Dyes, on the other hand, are soluble in solvents and are commonly used to color textiles and plastics. They work by molecularly dissolving in a solvent and selectively absorbing certain wavelengths O. F light. This selective absorption creates the perception of color. Color mixing and blending are intriguing topics that involve the interaction of light with pigments and dyes. By understanding the chemistry behind these processes, we can appreciate the science and artistry behind colors and create visually stunning works of art. Colors are perceived by our eyes through the interaction of light. When light encounters an object, it can be absorbed, transmitted, or reflected. The colors we see are a result of the light that is